Hello, guys. My name is William Brendel. I'm Chief Scientist Officer and co-founder of Heali. And today we are going to talk about big data and AI in nutrition. So maybe some of you know that, but nutrition is completely underrated. There's over 400 medical conditions that are affecting over 50% of the US population, where scientific studies shows that with a better nutrition, you can reduce those symptoms. And I'm talking about medical conditions like IBS that affects 40 million of people in the US, diabetes, over 35 millions, cardiovascular diseases, over 30 millions, and I can go on and on. In addition, the cost of going to see a doctor or getting some pills, some medicine for health insurance per year in the US is over $275 billion. So it's a huge cost for them. And you may say, 2021, there's got to be an app for each of those medical conditions to help you navigate your journey. Well, it turns out that among all the nutrition-related apps, over 95% of them only tackle weight losses. The field of nutrition, in addition, has made very slow progresses. 2,500 years ago, Hippocrates, a Greek scientist, said, "Let the food be the medicine and the medicine be the food." And yet, 2,500 years later, nutrition is mostly viewed in the US as basic food suppression and calorie counting. So when I entered that field, I had two main questions. The first one was, why is eating better and smarter so difficult? And how can big data and AI help? So in the remaining of the presentation, I'll start with a couple of fun applications in nutrition. And then I'll move towards our work here at Heali. So first off, the field of nutrition is still making some decent breakthrough using AI. And one of the first field of application is for food crossbreeding. Plant-based alternatives are really critical nowadays for worldwide food sustainability and food availability. And I'm going to take an example with yellow peas, because they are the fastest growing protein source for plant-based meal alternatives. And just in terms of market, they are estimated to be worth over 140 billion in less than a decade. A company called Equinum partnered with Good Meals, and what they did, they use and developed AI algorithms that they pair with standard genomics to simulate a new variety of yellow peas. And for that, they collected and used a huge seed bank made of exotic, ancient, and modern varieties. And they show amazing results. And they even extend their technology to other breeds like sesame seeds. Another example is in food design, when manufacturers try to come up with a new product. Typically, it takes over 150 iterations before a new formula is commercialized. And if you're really like one of the top-notch experts in the field, it's going to take you only 50 iterations, but it's still a lot. And in addition, experts in those fields, they have biases towards their own taste. So McCormick's partnered with IBM, and what they did, they trained the system on over 100K food product formulas accumulated over a decade. And they build a pipeline where the computer is assisting the expert in refining those iterations and those formulas. And out of that, experts have less trials, and it also eliminates greatly human bias in the process. Another interesting field in AI and big data in nutrition is trying to discover a user diet and automatically suggest meals. And one really fun and unexpected application is big data for bowel disease detection via student analysis. So the goal here is to use big data and computer vision for digestive medical condition prediction. And so a health company called Seed collected over 100K of stool images, and they acquired a startup called Ogi, and used their stool recognition AI technology to predict gut-related disorders. And basically, it's pretty simple. As a user, you have their app, you log your meal, you take a picture of your stool, and then they analyze it. And based on the analysis, they suggest a potential disorder, and they suggest what you should eat. Another fantastic application is achieving precision nutrition via glycemic and microbiome analysis. So just to take a step back, for over 2,000 years, we try to analyze entire population, and based on those population, try to predict a once-fit-all nutrition diet. Precision nutrition try to personalize a diet to each user on the premise that because each individual is unique, they should have a unique diet. And for many people who have medical conditions such as diabetes or cardiovascular diseases, the glycemic response is key. So the Weizmann Institute in Israel and the lab led by Aaron Saul, what they did, they studied 1,000 of participants. The study was lasting 1 week. They monitored their glycemic response via a small portable device, and they designed an app so that participants would log every meal on it. And they normalized all those meals so that they have the same amount of calories. And what they realized two things. They realized that there was a large glycemic response variance across subjects, but within the same subject, the glycemic response was consistent, meaning if you were a participant and you were eating a chocolate cake on Monday, and you were eating that same cake on Tuesday, your glycemic response for both days with respect to that cake would be similar. And really what they proved that there's no once-fit-all diet. Nutrition has to be personalized because the glycemic response was very different. Some people had a high glycemic response to rice, others were having a low glycemic response to rice. But even more surprisingly, some people who had a high glycemic response to rice had a low glycemic response to ice cream, which is counterintuitive because you would think that if you eat ice cream, you'll get way more sugar in your blood than if you eat rice. But it's not the case for everyone. So nutrition has to be personalized. It was a huge breakthrough in the field of nutrition precision. And also because the glycemic response was consistent for each subject, they showed that nutrition preferences are learnable on an individual basis. And they went further. They combined the glycemic response with my DNA sequencing to really build a system that is providing meals that are hand-tailored for each users. In the following, I'll talk a little bit about my work at Heali and more precisely how we power the nutrition with big data and AI directly for the consumer. And before I dive into the detail, I really want to set up the problem statements. So on the left, what you have is a food graph, which pretty much every nutrition labs and companies are collecting. And the food graph is made of nodes, and each node is a food item. In addition, each node, meaning food item, carries a set of attributes, like food type, meaning, am I a dessert? Am I, part of dinner? Am I a product I can buy in a grocery shop? They carry nutrition facts. They carry a list of ingredients if you're a recipe or a product, and so on and so forth. There's a long list of attributes. And edges between nodes represent similarity between nodes. Like, are those two food items part of the same diets? Or do they appear in the same recipes? Do they have similar food types? And in general, do they have similar attributes? On the left, on the left, you have the food graph, and on the right, you have the user graph, right? Which represent our consumers. And similarly to the left graph, on the right, you have nodes, and each node represents a user with some attributes like their demographics, their biometrics, their medical conditions, symptoms, food habits, etc. And edges between users shows if they're friends, if they belong to the same community, if they're following the same diet, if they have the same medical conditions, and so on and so forth. And so once you have those two graphs, what is the goal? The goal is to map those two graphs using AI techniques such as NLP, data mining, reinforcement learning, unsupervised learning, and so on and so forth. Because once we have those mappings between the food graph and the user graph, you solve problems such as personalized nutrition, precision nutrition, targeted food breeding, meal planning automation, and so on and so forth. Once the problem is set up, you have those two graphs. What are those challenges in doing the mapping? So first off, when you have the food graph, right, when you're building that, it is far from being trivial because the available data is highly unstructured. And I'll go over the details in the following slides why it's highly unstructured. It's a ton of typos and errors, and there's a lot of hidden data from food manufacturers and the rest of the industry. And the reason being you have all those challenges, it's because the FDA and USDA, that are governmental associations, organizations, only impose a loose and restricted set of requirements to those food manufacturers and for the retailers. If they were imposing a more strict set of requirements, the data would be a lot less unstructured with a lot less typo and errors. And food manufacturers and retailers, they wouldn't be able to hide so much data. And again, in the following slide, I will give you an example of that. On the user graph, the data is really hard to collect accurately and consistently. Why? Because, well, even if you provide an app to people, it's hard to create a habit to log every meal and every symptoms every time you eat. In addition, it's hard to maximize diversity in studies. For 2,000 years, there has been a lot of nutrition studies, but the population they were studying was very small, few thousand of people, sometimes dozens of thousands of people, but they were all very localized, geographically speaking. And so the analysis of it was biased toward your population. You were liking diversity. It's not like you were studying millions of people in the US, in Europe, in Africa, in Asia. Because if you were doing so, you would see that a one-fits-all diet doesn't work. It depends on everybody's characteristic. And in the past 2,000 years, it was also really hard to million and billion of users because they simply didn't have apps, didn't have the technology. And in addition, even if they had those apps, and even if they had population, still as of today, the results are mainly analyzed and interpreted by humans, which introduce a huge bias in the conclusion of those results. So speaking of technology, it still needs to be developed. And there's a lot of work that needs to be achieved there. And to develop that technology, you need AI researchers. However, that talent pool is very scarce in the domain of nutrition because those young AI researchers, they prefer building rockets that go to Mars or building self-driving cars than joining the field of nutrition. Joining the big tech industry in the Silicon Valley is much more appealing for them. And in terms of available technology, right now, the solutions, as I mentioned earlier, really focus on calorie counting and weight loss. And the reason being, it's because when you focus on this problem, even though you have highly unstructured data and it's hard to collect accurately and consistently, user data, it's still you're still in the safe zone. You still can use a lot of data, and it's still easy for the user once a day to take their weight, or once a week. So let me tell you a little bit more about our approach at Heali. We started with food graph, and our goal was to build a robust and comprehensive database. We collected over 30,000 raw food items, such as apple, carrots, resin, basil. We collected over 500,000 of products and 500,000 of recipes. And by product, I mean things you can buy in a grocery shop, like Heinz ketchup, like Amy's canned soup, etc. Just on a 2% sample size, we realized that over 75% of recipes that we collected had at least some typos, some corrupted data, or some data that were misleading. And similarly, over 55% of products had corrupted or misleading data. And so we were really astonished by that. And we dive deeper into the system, into the data, and we build, the first thing we did is to build some ML and data mining techniques to identify potential errors, to clean automatically the data, and to also uncover data that wasn't presented by food manufacturers and food retailers. And I'm going to show you an example. Let's assume you're grocery shopping and you need to be on a diet that restricts your intake of sugar for whatever reason, maybe because you have cardiovascular disease, or maybe because you're diabetes, or simply maybe because you're one of those people who really want to lose weight before summer. And so you grocery shop and you have a sweet tooth and you're looking at maple syrup and you're comparing two maple syrup products with the two following nutrition facts. And the first thing you realize is that on the labels, there's no daily value percentages for total sugar. And why is that? Well, because the FDA didn't really impose food manufacturer to provide those values and didn't really even design the set of rules for computing daily values. In addition, what you realize is that the product on the left only has 27 grams per serving of sugar, and the product on the right has 54 grams of sugar per serving. And you're like, oh my God, the product on the left is twice better in terms of sugar intake than the product on the right. But what you don't realize is that the product on the left defined the serving size to be 2 tablespoons, 30 milliliter, versus the product on the right, they said that a serving size is 4 tablespoons, 60 milliliter, twice as much. So of course, if the serving size is twice as much, per serving size, the total sugar is twice as much. So if you don't pay attention, as a consumer, you believe the product on the left is twice better than the product on the right. But if you pay attention, you realize actually they have the same concentration of sugar, they just have different serving sizes. And even though you're one of those consumers that do pay attention and realize it, you may ask, but wait a minute, for maple syrup, what is really a good serving size? Is it 2 tablespoons or is it 4 tablespoons? In addition, if you're a scientist like me, you may say, well, why don't we apply the European system that normalized everything to 100 grams or 100 ml? Well, the reason the US and the FDA and USDA created those serving sizes is to better reflect what you are going to eat at every meal, right? And because when you eat something, it's not just about the weight, it's also about the volume. Eating 100 grams of pasta is completely feasible. But if you want to eat 100 grams of lettuce, that's a lot of lettuce you're going to have to eat, because lettuce takes a lot of space, actually. Yeah. The way the leaves are shaped, it's different than a dense product like pasta. So really, volume matters as well. And so that's why you can't blindly normalize everything to, you still, when you do nutrition analysis, to fall back to something that users will eat on a daily basis. And now you continue your journey, grocery shopping, and remember you have a sweet tooth, and you're like, well, maybe I can substitute my sugar intake from maple syrup with some fruits, because I was told that fruits are amazing for me. And you stop by dates, and you realize that dates has even more sugar than maple syrup for roughly the same serving size, right? If I assume that 1 liter is equal to 1 kilogram, 30 ml is roughly, in the same ballpark as 40 grams. And you're really surprised. And you're really surprised by that because you were always told by your dietitian that you should eat fruits. So you continue your journey, you skip on dates, and you find mangoes. You like an exotic product. And if you don't pay attention, you're going to believe that that mango has 51 grams of sugar. If you pay attention, you realize that that number is per package. And you go back to the other number, which is per serving, and it's still 24 grams of sugar. So you're like, wow, I didn't realize that fruits carried so much sugar. And you continue your journey, and right after looking at mango, you look at mango juice, And what you see is that mango juice is very similar to mango, right? 24 grams of sugar, but 20 grams of added sugars. How come mango juice has so much added sugars? And your dietitian told you that among all the sugars you can take, added sugar is the worst because it comes from fully processed ingredients. And we know that when food is highly processed, it's really bad for your system. Now, here's the deal. The deal is that maple syrup is highly processed as well. But because it's a syrup and because they claim that it's pretty much raw sugar, even though it's highly, highly processed, they don't really have to say that their total sugars is added sugar, even though it should really be considered as added sugars. They exploit some loopholes in the FDA guidelines. And if you're not aware of that as a consumer, you look at that mango juice and you're like, sure, that mango juice has slightly less sugar, but pretty much all the sugar is added sugar. So I'd rather pick my maple syrup as my sugar intake versus mango juice. And so I just showed that nutrition facts are really misleading because the FDA and USDA requirements are too loose. First of all, only 9 nutrients are required to appear on labels. Food manufacturers, they're not required to put vitamins, they're not required to put iron, copper, they're not required to put the remaining 200 other nutrients. And while you see a lot of time those additional nutrients at the bottom of the label, if it's a nutrient that will be in general harmful for their customers, they're not going to report it. Even worse, if a nutrient, even among the list of required nutrients, is below a certain threshold in quantities, they can claim it's 0% DE. I just show you as well that the guidelines are very loose about when to report added sugar under sugar. And also for the serving size, the FDA guidelines for syrup, juices, fruits, vegetables, and so on and so forth, they have the full questionnaire for you to fill to arrive to your serving size. Well, once you find the suggested serving size by the FDA for your product, you can put up to 200% of that serving size, all the way down to 50% of that serving size. And so if the FDA recommend a food manufacturer, well, for maple syrup, the recommended serving size is 60 ml. What do you think a food manufacturer will put? They have the choice to put a serving size between half of it, 30 ml, all the way to twice, 120 ml. Well, they're going to put 30 ml because the amount of sugar is going to look a lot less if they report 30 ml as their serving size, hence their product is going to look better. And as I showed, you can have exactly the two same products, different brand, but same product. And if they have different serving sizes, one may look better than the other one. In addition, if you are a food manufacturer or food retailer with 20 or over 20 shops in the US, right? Then you are required to put all your products information in the US database. But we went through that database and we realized that it's not really reviewed and enforced because it's full of typos, errors, and even when the USDA require you for the last 2 years to specify the amount of added sugars, not all manufacturers do still as of today. And there's a good reason why. It's because there's 500,000 of product on the USDA database. And so it will be extremely challenging for the government to hire people to go manually over it, or to hire, or it'll be extremely expensive for them to hire AI researcher to develop a whole smart pipeline to catch up those errors. Things that we did here at Heali. And this is our solution to tackle this unstructured and completely normalized data. Instead of talking about nutrients in an absolute manner in terms of quantity, we developed an ML engine to rather assess the quality or the impact of each nutrients based on individual metadata and preferences, and also based on the food attributes. And so, for example, if you're someone who has diabetes and you need to monitor your amount of sugar, well, not all sugars are born equal, and the impact of sugars coming from fruit be lesser than sugars coming from high fructose corn syrups, because the very molecules that are defined as sugars, and there's many types of different sugars, those molecules coming from high fructose corn syrup will be much more harmful than molecules coming from fruits. In addition, fruits will carry a lot of other benefits. They will give you a good fiber intake. They will give you antioxidants for many fruits like blueberries or any other type of berries, and so on and so forth. So we build an ML engine to tackle that. In addition, we provide to our consumer a text, not just number, but a text that summarizes the whole analysis to demystify those numbers and to really clarify what's going on to our consumers, so that instead of being confused behind, reading food labels, then in plain text what's good and bad for them and why it is. And in addition to that, when available, we provide the link to the nutrition research to add the last nail in the coffin in terms of science, and to really play this educational role that they don't have if they still are looking plainly at food labels with not much awareness about what's going on those labels. Now, what if I have vitamin A and vitamin C deficiency, and I need to be on a high vitamin A and vitamin C diet? And for example, you take that kind of soup, that soup has potatoes, carrots, peas, so you would expect that soup to carry a lot of vitamins, but there's no mention of vitamin A or vitamin C on the nutrient fact labels, because those nutrients are not required by the FDA label. And so our solution was to train an ML engine to estimate the quantity of each ingredient in a product. When you look at a product, you see the list of ingredients, but they don't provide you the quantities. We developed an ML engine to reverse engineer that. And once you get those quantities, you can reconstruct the product nutrition facts as a weighted linear combination of ingredient and nutrition facts, and unravel those hidden nutrients.
You have 2 minutes to wrap up the session.
And other applications of ingredient quantity estimation are with respect complex sugar quantities for low FODMAP diets, and you can also transfer that technology to estimate the quantities of ingredients in the restaurant menu items. And I'm going to skip on the restaurants because I only have 2 minutes left. But what's the next step? Our next step is to tackle precision nutrition, to connect with wearable devices and fully integrate the analysis to achieve fully personalized nutrition. And so in conclusion, nutrition is making good progress, and thanks to big data and AI. Solving nutritionality problem is helping with food availability, food sustainability, food quality, health costs, people condition and lifestyle. And the key to success is to make the data more clean, visible, and unbiased, to still innovate technology that map the food graph and the user graph, and to integrate with new wearable devices and sensors. Thank you.